Hi everyone, thank you for joining Site 24/7's webinar series. I am Mahalashmi and I'll be hosting today's webinar with Manikantan, our technical expert. Without further ado, let's get started. I'll quickly run you through what we have in store for you today. In the agenda, before we start out with today's main topic, I'll acquaint you with Site 24/7, our monitoring tool, and what it has got to offer your environment. Then we will discuss the critical challenges in monitoring the Kubernetes environment and the pivotal metrics that you should consider while monitoring them and why you should be considering them. Adding to that, we will also discuss a few best practice recommendations and how implementing them can benefit your environment. After this, we will discuss how Site 24/7 as a Kubernetes monitoring tool can help you optimize your clusters. During the course of webinar, if you have any questions, you can actively post them in the chat box, which will be taken up by towards the end of the session. So yeah, towards the end of the session, we also have a Q&A. Now, let me introduce you to Site 24/7. In the year 2007, Zoho's IT management arm, Manage Engine, began developing Site 24/7 to cater to the needs of a rapidly growing IT environment. Site 24/7 is a cloud-based monitoring platform that helps IT and DevOps team of all shapes and sizes to break down the complex relationship between the IT infrastructure, application, customers, and businesses. It's been 15 years now, and presently, working AI Ops Power digital experience monitoring, ITOM, and observability solution for IT and DevOps. We also further provide cloud cost optimization and hosted status pages for businesses to thrive. We'll learn more about Site 24/7 further down the presentation, but for now, let's get started with the topic of the day. The topic of today's webinar is Unified Container Visibility, Managing Multi-Cluster Kubernetes Environment. Monitoring complex infrastructure comes with various challenges due to its sheer scale, diversity, and interdependency of components. Ensuring these challenges are taken care of is a crucial part of your infrastructure's stability, performance, and scalability. Keeping track of layered architecture requires attention to detail, and Kubernetes is one such environment. Here are a few commonly faced Kubernetes challenges. In the Kubernetes cluster, you must deal with multiple servers and private and public cloud services. So whenever a problem occurs, there are many metrics, logs, and other components that you need to investigate. In the past, monitoring and logging was simple because most applications are monolithic architecture. Nowadays, in a race to simplify application deployments, we take assistance of dynamic provisioning, automated configuration tools, and Kubernetes for orchestration. All of these add a layer of complexity into your environment. In addition to increased complexity, new applications are being designed for microservices, where a number of components communicating with each other has increased by the order of magnitude. Each service can be distributed across multiple instances, and containers move across your infrastructure as and when needed. Apart from this, Kubernetes is also a rapidly scaling environment that keeps spawning new resources every day. Kubernetes containers are constantly being created, altered, and removed. This creates challenges in monitoring and debugging distributed application at a scale, often resulting in reliability issues. Kubernetes is also not interoperable by default with other services and applications, meaning there's a lack of streamlining in communication between apps. Also, in comparison to development and QA environment, its production environment may have performance issues. For example, migrating and operating cloud-native apps on Kubernetes makes communication between applications complex. As companies expand, they aspire to scale up and increase their footprint. But with errors in integration and with an infrastructure that is poorly multi-cloud, on-premise, and hybrid cloud orchestration, expansion can be a difficult undertaking. One of the most commonly heard Kubernetes challenge is the lack of visibility. It's hard to see what's inside a container. The fundamental working of depends on how efficiently it packages and isolates application to consistently deploy them anywhere, anytime. This makes them great for operation, but at the same time turns them into a black box that is impenetrable to troubleshoot. Containers are also very short in nature, meaning they don't last long. A majority of containers live for less than 5 minutes. This creates a high level of churn in your environment. Before having time to gauge what's happening to your old ones, it's already 5 minutes and you'll have to move on to the newer ones. And this is why you would require a monitoring tool that can provide you with granular visibility and can trace down every process, file, network connection for faster troubleshooting. The critical challenge in Kubernetes is to ensure all your clusters and the workloads inside them are healthy and optimally functioning. This requires collecting and analyzing Kubernetes specific metrics like pod status, node capacity, and workloads running from a variety of sources. This can be collecting metrics, logs, and other data from your container environment can be complex and resource intensive, especially if you run a large scale environment with nodes and workloads. This can also be resolved with the help of a tool that can auto discover the components in your Kubernetes environment and collect all the metrics without dampening your workflow. Now that we have taken a look into what could derange your Kubernetes performance, let's discuss on how to prevent it. Kubernetes monitoring is an ideal way to ensure optimal performance of your container environment. To obtain the thorough benefits of monitoring, your Kubernetes environment should be monitored for the right set of parameters. With that, let's proceed to our next section. What are some of the Kubernetes specific metrics that you should be mindful of and why? The Kubernetes critical metrics can be broadly classified into cluster, node, pod, container, and workload or application metrics. Amongst all of these components, monitoring your cluster-specific metrics are of most importance because they give you an aerial view of your environment. Some of the cluster key metrics to look out for are the number of nodes, pods, containers, and workloads, along with their current statuses. You can also look out for the top 10 nodes in terms of CPU and memory to effectively manage your resources. As a part of your monitoring plan, it is also vital that you include node-specific metrics that allow you to pinpoint available resources for subsequent operations. Keep an eye on system load, memory usage, disk I/O, available disk space, network traffic, etc. Now, monitoring pod-specific metrics lets you know how a pod is performing from a resource perspective. If an application is running in a pod and it gets a spike in requests that is above than usual, it may need to scale horizontally. If a pod keeps getting increased utilization need, it's time to scale its limits for CPU and memory. An important metric that you should monitor in terms of your pod is the top 10 metric for CPU, memory, and network. That way, it is easy to screen the pod that needs more resources and keep a close eye on it for future turbulence in performance. Now, a pod could be running and operating as expected, but that doesn't necessarily mean the underlying container or the applications running inside the container is up and running as expected. Monitoring container-specific metrics allow you to assess where you are in terms of the metrics that you have configured. And tracking application metrics measure how the application is performing. Tracking application metrics measure how your applications are performing. These metrics are specific to the applications and relate to its business logic. For example, a web page application may provide metrics detailing to the number of users accessing the application, the user experience metrics, and the conversion action. Now, apart from monitoring your Kubernetes specific metrics, it is also important that you monitor the log metrics for your Kubernetes. Some of the log metrics that you can monitor are the Kubernetes audit logs, the Kubernetes event logs for nodes and pods. Tracing these logs can help you immediately find out who did what, where, and when without having to go through huge collection of data. Now that we have jotted down the critical metrics to keep tabs on, let's narrow down a few best practice recommendations for optimal Kubernetes performance. The first among these would be to baseline your pods and set minimum and maximum limits for your pods in terms of resource utilization. By setting sensible limits and requests on how much CPU, memory each pod uses, you can maximize the utilization of your infrastructure while ensuring smooth application performance. If you do not specify a CPU limit, the container can use up all the CPU resources available on the particular node. This can cause the containers with high CPU utilization on the same node to slow down. And sometimes Kubernetes specific components like Kubes can also turn unresponsive. Baselining your pods can help you with out-of-memory issues, pod eviction, and also cost optimization. Pod eviction, because whenever a node runs out of resources, what it does is it initiates an eviction process and terminates the pod. Cost optimization, because overutilization means over provisioning, and over provisioning means ultimately you're overpaying. The second would be to introduce resource tags. Labeling can ease the order and management of your resources into Kubernetes clusters, nodes, pods, and containers. Allotting tags and labels to resources can help you quickly identify and group related resources together to take up operations and function them as logical unit. Implementing resource tag helps efficient resource management, easy detection and troubleshooting, and also effortless scaling and resource allocation. Now, how about I explain this with the use case? Consider an e-com application with multiple microservices. We shall name this app Zilgar. Each of its microservice is a pod in a Kubernetes cluster responsible for a particular function. When we denote all of these pods with a microservice name, in the case of this, we can denote it with its function name itself, like order taking, inventory management, payment, processing, and more. It helps tracking the performance of health and it helps tracking the performance and health of specific microservices just by filtering them using tags. And by filtering them based on labels, what you can get is an instant isolation of these metrics and be alerted for a particular microservice. Say there is a sale season and a particular microservice, if the payment handling app is starting to slow down, we will know about it immediately and we can fix it before the customer gets affected. Tagging extends just beyond troubleshooting. It is also a strategic tool for resource allocation. If you need to scale up this particular payment microservice due to increased demand, your tags provide a clarity to optimize your resource efficiently. A well-labeled Kubernetes environment makes navigation easier and efficient. Let me quickly show you the Site 24/7 client to let you know how this is done in Site 24/7. I hope my screen is visible. So for the ease of use, I've already installed the agent and I'm using an existing monitor type. For this, when you click on a particular node, you will be taken to that node's dashboard. And this window has identifiers, or what you call a Kubernetes label, associated with it. Now, when it comes to labels, what you can do is you can name it according to your wish. You can name it with regard to function or any logical reason that seems applicable to you. This also helps us pinpoint and filter out the particular node required for particular action. With that, let's move on to our next practice recommendation. The fourth one, sorry. The third practice is leveling up your alert game. Monitoring and alerting go hand in hand. Ensuring that alerts are sent out when a metric extends a certain preset threshold is an important part of monitoring. In most cases, alerts indicate that something is wrong with your environment and it needs your immediate attention. But alerts can also be set for regular cases, for routine system checks, for reports, and other cases. For example, say your pod has restarted and you want to know every time your pod gets restarted. What you can do is you can configure an alert for this particular function and remain worry-free, because whenever your pod gets restarted now, you'll be alerted of it. However, it would be best if we didn't overdo in case of alerts, because they can get quite overwhelming quickly. Some ways to ensure that you don't suffer alert fatigue. What you can do is you can correlate issues and reduce the number of alerts that you send out. You can also limit the time duration of receiving alerts by prioritizing what you need to be alerted for. You can choose to be alerted outside office hours. You can choose not to be alerted in case of non-sensitive issues outside office hours. And above all, you can make sure that your alerts have enough and adequate contextual information for you to decide on a course of action. All in all, alerts help you stay in touch with your data real time. After baselining, setting threshold, and prioritizing your alert requirements, ensure that the configured alerts you via various media to always have your containers in your radar. You can choose to be notified via push messages, SMS, emails. The fourth point would be to monitor your deployments. This is for you to proactively evade pod failures. Monitoring replica sets, which are part of deployments, is crucial for preventing pod failures and maintaining application stability in Kubernetes at all times. Replica sets ensure that the desired number of identical pods are running at the backend all the times. How about I show you the Site 24/7 client to explain a bit more on this? I hope my screen's visible. So in case of deployments, you go to directly the deployment tab, and you have the count of replica sets here. Now, when you keep track of replica sets, you need to monitor the desired, available, and unavailable sets of replicas. Now, when the desired pod counts are higher than the available number of pod counts, you can conclude it for a pod failure. In this case, the available and the desired number of pod counts are same. So everything is smooth sailing in your environment. You can note the deviations from the desired state and the actual state and initiate a pod to replace and restore the count. Through continuous monitoring, you can also identify issues with pod crashing, resource exhaustion, and network problems. This proactive approach prevents service disruption and maintains application availability at all times. This insight gained from tracking replica set helps you to allocate your resources by not overdoing or underdoing it. It also ensures that applications have necessary number of healthy pods for consistent service delivery. No. The fifth and final practice would be to entrust Kubernetes visibility to a centralized container monitoring tool. This can maintain multi-cloud and self-managed Kubernetes setup altogether. The rapidly growing digital landscape requires agile and seamless monitoring tool to embrace cloud native as well as on-premise self-managed. Therefore, it is important that we have a centralized container monitoring tool to bridge the gap of communication between cloud and self-managed setup. This smoothens operations altogether and gives you the best of all the worlds. Monitoring a multi-cloud environment and self-managed Kubernetes setup offers distinct advantages in optimizing your containers performance. In a multi-cloud scenario, monitoring across various cloud service providers gives you a holistic view of resource utilization, allowing you to allocate resources without under or over provisioning it. Simultaneously, monitoring self-managed Kubernetes cluster offers you granular insights into cluster-specific configurations and performance bottlenecks. By placing all the essential KPIs into one pane, you attain a single console view rather than switching between multiple tools and interfaces. With a unified console, all your metrics are in one plane, and you can correlate these and observe trends and outliers patterns over a period of time and identify potential issues to take actions on them and address them effectively. Let me give you a very personal Site 24/7 use case for this. An IT company that has recently transitioned its application to a cloud-native architecture is utilizing both cloud-based Kubernetes as well as self-managed Kubernetes cluster in their on-premise data center. They run a variety of mission-critical workloads, including the user-facing web application, microservice, and big data processing. With multiple Kubernetes cluster and various application components spread across their cloud and on-premise environments, the company now faces a challenge in monitoring and maintaining the health of the performance of their application. There's a need to have a comprehensive view of their entire ecosystem to promptly detect and resolve any issues that might arise. As a solution to this problem, Site 24/7 had offered them a centralized monitoring tool that provides real-time insights into health, performance, and resource utilization of a cloud-native and self-managed Kubernetes setup. With the help of this tool, they have now achieved a holistic view of their entire infrastructure, enabling them to quickly identify and prioritize issues. They are now alerted during resource bottlenecks, ensuring that applications have necessary resources to perform optimally. They also get insights into application traffic patterns and resource consumption to help them make informed decisions about scaling up or down based on actual usage. Furthermore, they can now aggregate logs from all the clusters, making it easy to trace issues across different components of Kubernetes environment. Now, let me quickly show you the Site 24/7's dashboards in Kubernetes. So, I hope my screen is visible. This is a health dashboard, or what we call it a cluster dashboard. It gives us with a comprehensive view of all the Kubernetes resources. It has nodes, pods, service, containers, current status. It also has a separate section for problematic nodes, pods, and containers. You also can segregate top nodes based on CPU and memory allocation. Apart from this, we also have an inventory dashboard that has all the resource types color coded based on active, suspended, and workloads under maintenance. You have a namespace dashboard that gives you with a comprehensive idea of all your workloads. You also have separate dashboards for nodes, pods, and containers. You can also leverage dashboards for other Kubernetes specific components too. Companies often spend colossal amounts on sophisticated monitoring tools, but still end up fighting severe IT issues. But with the right tool like Site 24/7, you don't have to worry about your container or any infrastructure issues. Let me quickly get you reacquainted with Site 24/7 before I hand the session over for Q&A. Site 24/7 is a robust and efficient all-in-one monitoring tool for your server, network, website, database, virtualization stack, container, cloud, and application. We also provide hosted status pages and cloud cost optimization services. We have 100 plus log type and 100 out-of-the-box plugin support with features like intuitive dashboards, IT automations, AI-based insights, and numerous third-party integrations. You can remediate better. We have 13,000 customers across the globe, and we comply with all security standards because we undergo a security audit every year where an evaluation of our design and operative effectiveness is done diligently. You can also know more about us through all these contact information, or you can always check us out on our webpage. With that, I conclude the webinar and hand the session over to Mani for Q&A. Mani, over to you. Guys, since we don't have any questions for this particular session, Mani, we had in the previous session, we had a question related to what happens to the terminated pods. If you could give us an answer to that, I think it would be helpful for all of us.
Sure, absolutely, Maha. So yes, the pods have the nature to automatically scale up or scale down based on the usage or the traffic that's flowing through each of the containers. So inside 24/7, we have an option to manage these terminated pods. So you have the option to either stop monitoring those terminated pods so that you won't get any alerts on that. So this can be automatically handled within Site 24/7, and we have a dedicated option for that. So if the pods are going to get terminated, so you don't need to worry on those, and these can be stopped from being monitored as well.
Sure. Thanks, Mani, for that. I think that's it with the webinar session today. Thank you for joining us. You can always check us out for the upcoming webinars in the webinar section of our webpage. Thank you for joining. Have a great day.